So we're going to start with some warm-up problems. These are going to reteach us some skills that we maybe haven't seen in a couple chapters, but we have seen these things before. So if I look at letter A, I have negative 6 times 3x minus 5. Do you remember seeing something like this? We take the number that's out front, and we're going to multiply it to both of those things on the inside. Remember, we call that distributing. So I'm going to distribute this negative 6 to both pieces. Now, the coefficients are going to multiply together. Negative 6 times 3 is negative 18. That variable is just going to stay how it is because there's only one variable. Same thing when I multiply negative 6 times negative 5. That's positive 30. It's in standard form. Do we remember from chapter 6, unit 6, when we were doing exponents? What's our rule for when we multiply exponents? What do we do with their variables? When we multiply variables with exponents, what do we do with the exponents? Read. We're going to add the exponents. So that's like x to the third and x to the first here. My coefficients are going to multiply together. Negative 4 and 6 make negative 24. And then the x's, x to the third and x to the first, make x to the fourth. So maybe make yourself a note if you didn't remember that. We're adding the exponents together. Same thing happens in letter C. Anything that has the same base, we can add their exponents together. So the negative 2 and the 6 are my coefficients. They make negative 12. What about the x's? I have x to the, what power? X to the first is here. So x to the fourth. And then what about the y's? Also y to the fourth. Beautiful. We remember those exponent rules, yes? We're going to use them today. So our rule for when we multiply polynomials is that we are going to multiply each term of the first polynomial to every term of the second polynomial. Today, what we're going to focus on is just one monomial times different lengths of polynomials. So we're going to start out nice and easy first. We're going to remember those rules for our exponents. When I take 3x times 2x minus 1, I'm going to start with 3x times 2x. The coefficients multiply to 6. The variables are each x to the first and x to the first, so they should add together to x to the second. Beautiful. Same thing with the next one. 3x times negative 1. I'm going to multiply those coefficients together. There's only an x to the first, so there should only be an x to the first in my answer. Straightforward enough. We're going to make sure that those are in standard form. Same thing with b. We're going to go ahead and multiply negative x to 2x to the second. So the negative and the 2 multiply together, negative 2. What about the x and the x to the second? Become x to the... This is x to the first and x to the second, so that should be x to the third. The exponent is not negative. The exponent is positive. Then negative x times negative 5x. So the negative and the negative 5 become a positive 5. X to the first and x to the first become x to the second. Questions on that? The only thing we're doing differently in letter C is now the monomial, the single term, is in the back instead of being in the front. We're still doing the same process. So we're going to do x squared times negative 2x to the third. What does that get me? Perfect. And then I'm going to do negative 5 times negative 2x to the third. What does that get me? Positive 10x to the third. Questions on these ones? I'm going to make it a little bit more challenging. I'm going to add larger polynomials. So trinomials, polynomials, all that good stuff we're going to see. So look at letter A. I'm going to multiply negative 2 times x squared. That's just negative 2x squared. I'm going to do negative 2 times negative 2x. Coefficients together make positive 4. X variables together give me just x. And then negative 2 times positive 5 is a negative 10. What about B? Help me out. Start with this first multiplication. X times x to the third is x to the fourth. X times negative 6x squared. Negative 6x to the third. I'm adding this exponent of 1 onto all of my x's. So x times 4x is 4x squared. What about x times negative 5? Negative, read.
I don't have the answers, but can I read the back?
Sure.
Is that a 2 above the x?
This is a 2, yes. Okay, can we try another one? Letter C, what do we got? Anybody want to give it a go? We can go step by step. Autumn, you got it? Beautiful. Next. Okay, and then lastly? Perfect. Questions on that one? I'm going to keep going. D is backwards. The 6H is on the right side. That doesn't change anything. I'm still going to do these two multiplication problems. Negative 5H to the second times 6H. Coefficients together, negative 30. H's together, H to the third. Negative 7 times 6H, negative 42H. Go ahead and try E. Anybody got it? Branson, turn around. Jaden. Plus 12x to the third, but yes. Perfect. Okay, the last one. Now I'm looking at something a little bit more challenging because I have multiple variables. Remember, we are only adding the exponents together if they have the same base, the same variable. So for F, this first pair, I'm going to multiply the coefficients together. Negative 6 times 3 gives me negative 18. Then I'm going to talk about the x's. X to the what power? Third. This is like x to the first and x to the second together. What about the y's? Y to the second. This is x to the first. Y to the first and y to the first make y to the second. Same thing for the second one. Negative 6xy times 2x to the fourth, y to the third. Coefficients together, negative 12. X's is x to the fifth. Y's are y to the fourth. Any questions on these? This is the majority of your homework, and we're going to make it a little bit more complicated tomorrow. Yeah, did I do something wrong? Remember how I said yesterday when it's multiple variables, I don't care as much about standard form because it's kind of hard to tell, but you could. Yeah, I might do that. Okay, last section. This does come up on your homework, so we do have to talk about it. We've seen this word, greatest common factor, before. I think you talked about it in middle school. Does anybody remember what a greatest common factor is, James? Yes, it is. Yes, the largest number, let's write largest number that can be divided evenly into a set of numbers, which is a long definition that just means what is the biggest number that we can take out of all of those numbers evenly, right? So for example, if I look at letter A, what's the greatest common factor of 3 and 9? 3. 3 goes into 3, 3 goes into 9 evenly. That's the largest one. What about 8 and 20? 4. 4 goes into 8, 4 goes into 20. That is 4. What about letter C? Does it have nice factors of 37? No. So the largest number that can go into both of those is 1. So when they don't have any factors in common, their greatest common factor is going to be a 1. Then we talk about greatest common factors between 3 numbers. So now we got to compare all 3. What about letter D? 12, 36, and 42. What do we think? 12 goes into 12 and 36, but 12 does not go into 42. So we got to pick something else. 6. 6 goes into all 3 of those. Perfect. What about letter E? What is it? It is 3. 3 goes into all 3 of those. And then F? 2. Perfect. Any questions on this?